Okay, in this lesson we're going to do another one of my very favorite problems. A lot of these problems have a history to them. When I was a graduate student at Iowa State University, I kind of volunteered to help create the midterm and finals. I really got into teaching way back then. And I came up with this problem. I just realized it was really an interesting one, and I've sent it to a few authors since then, and I've seen it appears now in calculus books. I don't know if they got the idea from me or if someone discovered it otherwise. But anyway, lots of excuse me, interesting stuff. And part of it is the graph of the function is kind of surprising. So let's see what we get. So here we go. Domain x can't be 0. And then intercepts. Well, let's see. There's no y-intercept since x can't be 0. And notice that e to anything is always positive. So this the function will never be 0. It will always be positive, so there are no intercepts. None at all. Okay? Symmetries. So you stick in negative x, and you get e to the negative 1 over x, which, just look at that and you say, well, it's not the original function, nor is it the opposite of the original function. So there's no symmetries. I should say it's not the negative of the original function. Okay? Well, pretty easy so far. Things become more interesting when we look at asymptotes. Okay? So, let's look at them all carefully, one at a time. We'll first look at this function as x goes to infinity. I'll kind of go from the easier to the hard. Okay? So, here's the way I teach this again. I've taught this problem many a time. Here's the graph of 1 over x, and here's the graph of e to the x. Okay, so we're putting these two together. This is the composition of these two things. X is first going into here, and then that's going into here. So let's think. As x goes to infinity, that is, it gets really, really large. What happens? 1 over x is going to get really, really small. It's going to be going towards 0. You don't need to even look at the graph to see that. You can just see it. As x gets really, really big, 1 over x is going to be going towards 0. So this is going towards 0, and so that's what e sees. So now you look at e and you say, what happens to e when it sees something going to 0? Well, it looks like you're going to 0 from positive numbers. So here, as we approach 0 from positive numbers, e is going to be approaching 1. So this whole thing is just going to 1. So that's important to know. Let's write it over here. Okay? Now what happens as x goes to minus infinity? Well, same sort of thing. As x gets to be a really, really large negative number, 1 over that, a large negative number, 1 over that is going to become a very small negative number, close to 0. It's going to be coming in closer and closer to 0 through the negatives. So you look at e and you say, what happens as you get closer and closer to 0 through the negatives? This thing is becoming a small negative number. As this thing approaches really, really small negative numbers approaching 0, well, e just heads to 1 again. So same thing as before. Okay? Now, I've invited you before, but I'll invite you again, especially for this one. Turn off the video, or pause it, and you answer the question, what happens as you approach 0, let's say from the right? Okay, we're going to approach 0 from the right. So, okay, I'm going to assume that you've paused it now. And let's give you the answer. Well, let's see. As x, first of all, we'll get rid of this. As x approaches 0 from the right, 1 over x is getting to be a very, very big positive number. So sure enough, x gets to be small, 1 over x is going to be a big positive number. What happens as you take e to big positive numbers? Here's e to the x. You take that to big positive numbers and look at what comes out. Huge positive numbers. Okay, it's going off to not only infinity, but infinity. Okay, it's heading there fast. Okay, so so there's the answer there. And then finally, what happens as x approaches 0 from the left? Okay, well, let's think of it carefully again. As x gets to be a very, very small negative number, 1 over a small negative number is a really, really big negative number. See that? The graph is telling you that. As you put in a small negative number, 1 over x is a big negative number. What does e do when it sees big negative numbers? Well, here's the domain. You put in big negative numbers, e goes off to 0. So kind of surprising, okay? It's kind of surprising to have something where it goes to infinity in one direction and goes to 0 as you approach 0 from the other direction. So that's one of my favorite things about this function, is just that part right there. Now let's do the rest of it. You take the derivative, and the derivative, this is going to be for increasing, decreasing, of course. And so you take the derivative, and the derivative of e to anything is e to that thing times the derivative of that thing. Well, let's see, what do I have? I have 1 over x, which is the same as x to the minus 1 power. What's the derivative of x to the minus 1 power? It's going to be minus 1 x to the minus 2, which is negative 1 over x squared. So the derivative of this thing is negative 1 over x squared, which I guess I can write as negative e to the 1 over x all over x squared. Okay, so there's the derivative. Now what do? We find out all the places where it's 0 or undefined. It's never 0, but it's going to be undefined at 0. So that's our only spot we have to check. If you put in, well, actually, just look at it, everyone. E to anything is always positive. X squared is always going to be positive. The negative is negative. Negative times positive is negative. So it's going to be negative here and negative there. This is the first derivative. And so the function is going to be decreasing here and decreasing there. Okay, have any idea what this thing is going to look like yet? Okay, so there's that one. Now, I think we have room to do it underneath. Let's just do the second derivative. So the second derivative, notice we're going to have to use the quotient rule. You take the derivative of the top. Okay, so the derivative of the top. Well, let's just think about this now. The derivative of this is this whole thing. See that? The derivative of e to the 1 over x is equal to this whole thing. If I look at the top here is the same as that thing right there, except I have a negative on it. So the derivative of the top, which is right here, is going to be the negative of this, which is just going to be e to 1 over x all divided by x squared. There's the derivative of the top, times the bottom, which is x squared, minus the top. Well, if you minus the top, you're going to end up with a plus e to the 1 over x, times the derivative of the bottom, 2x, all over the bottom squared, which is x to the 4th. Okay? So, look at what happens. First of all, this divides out with this. I can factor an e to the 1 over x out of both of these things, and I'm left with 1 plus 2x, all divided by x to the 4th. So there it is, and I think I'm going to make my little diagram off to the side here. Where is this thing? This is going to be the second derivative now. Where is this either 0 or undefined? It's undefined at x equals 0. And this whole thing is going to be 0 whenever the numerator is 0. This will never be 0. This will be 0. Can you do it in your head? Well, I can do it up here real quick. 1 plus 2x is equal to 0. 2x is equal, of course, to negative 1. X is equal to negative 1/2. So here you are at negative 1/2. So let's check all sides. Throw in 150. Positive, positive, positive. Throw in something really close to 0 but negative. Just that's the way I like to think about it. Some really small negative number. So this is going to be positive. To the fourth is going to be positive. If this is a really small negative number and I add 1 to it, that's still going to be positive. So positive there. And then stick in some larger negative number, like, I don't care, negative 1 if you want. Negative 1 is going to be negative 2 plus 1 is negative. Positive, positive is negative. So the function is doing what? Concave down, concave up, and concave up. Okay, so let's see what this thing looks like. Okay, actually I'm going to draw it just a little differently than that. When you draw it, you want to think where are the interesting things. Here the interesting thing is at the origin and at negative 1/2. So I want to include as much or more space on the negative side than on the positive side. There we go. So here's what I like to do again. I like to notice that as you approach infinity and minus infinity, the value of the function is approaching 1. So I'm going to put like a dotted line here and here. That's one unit up. Okay. What else? As we're going to 0 from the right, this thing is shooting up to infinity, so I just put a little arrow like there. As you approach 0 from the left, we're going to 0. It's not defined at 0, so I'm just going to put a little hole right there, and I'm just going to put a little arrow saying I'm coming in towards 0. The only interesting point here is negative 1/2. Okay? And so at that point, notice you have an inflection point. So I think that does it. So it's decreasing the whole way. So I always have to be going downhill. So it's going to be something like this. Notice it's concave down. See that? That's concave down, at least it's meant to be. As soon as you pass negative 1/2, it becomes concave up. So now it's concave up, and it comes sliding into 0. Never quite hits it, but it comes sliding into 0. I don't know exactly what it looks like, but I'm going to have it coming down like that. There you go. What happens on the other side of 0? It heads up this way, and it heads along this way. It's always concave up, and it's also always decreasing. So I guess there's not many choices. Going to look something like that. Okay, so real interesting function. It shoots up to infinity on this side, and it comes in and kisses 0 on that side. So very interesting, very cool. Okay, in the next lesson, before we graph 2 more functions, we're going to have to learn one more important thing we need to know in order to graph them. It's called L'Hopital's rule. So that's coming up.